Welcome to section 5.4, String Library Functions. In this lesson, you will meet the standard functions that measure, copy, compare, and join strings. Let's begin. Welcome back. In the last few sections, you wrote string operations by hand. You counted characters with a loop. You copied strings one character at a time. In this lesson, you will meet the standard library functions that do this work for you. They are tested and fast, but some of them are dangerous. Let's learn both the functions and how to use them safely. This is the plan for this video. First, you will see why to use a string library instead of writing everything by hand. These functions live in the string.h header. Next, you will meet strlen, which measures the length of a string. It counts the characters up to the null terminator, but does not count the terminator itself. Then you will learn how to copy strings. You will see why the equals sign does not work, how strcpy copies, why it can overflow, and how strncpy limits the size. After that, you will compare strings. You will see why the double equals does not work, and how strcmp compares two strings and what its return value means. Finally, you will join strings together with strcat and the safer strncat, and learn the golden rule for keeping your buffer safe. Why use a string library at all? You already built these operations by hand. You measured length with a while loop, and you copied strings one character at a time. That teaches you how strings really work, and that matters. But rewriting your own string length function for every program is tedious and risky. One off by one mistake, one missing null terminator, and you have a bug that might not show up until much later. C's standard library gives you tested, optimized functions instead. They work on every C compiler. All the functions in this section are declared in the string.h header. To use them, you add an include line at the top of your file. Include angle bracket string.h. This is exactly like include stdio.h that you use for printf and scanf without this line. The compiler does not know these functions exist, and it will give you errors or warnings. The first function is strlen. It measures the length of a string. We have a character array named greeting holding hello. We call strlen on it and store the result in a variable named len. The word strlen stands for string length. Notice we print the result with %zu, not %d, because strlen returns a special unsigned type. The output is length 5. So what does strlen actually return? It scans forward from the start of the string until it finds the null terminator, the \0, counting the characters along the way. strlen of s returns the number of characters in s, not counting the null terminator. The return type is size_t, an unsigned integer type, which you print with %zu. So the string hello is 5 characters long, even though it takes up 6 bytes in memory. strlen does not count the null terminator. Before we meet the copy function, there is something that surprises beginners. You cannot copy a string with the equals sign. If you write dest equals hello, the compiler rejects it. An array name is not a variable you can assign to. That line simply does not compile. To copy a string, you need a function that moves the characters one at a time and also copies the null terminator. That function is called strcpy, which stands for string copy. Let's see strcpy in action. We have a source array holding hello and an empty dest array of 20 bytes. We call strcpy dest first, source second. After the call, dest holds its own independent copy of hello. One thing to remember about the argument order: destination comes first, source comes second. It is the same order as assignment, dest equals source. Think of it as copy into dest from source. The output is dest hello. This is the source string. It holds H, E, L, L, O, and then the null terminator \0. That is 6 bytes in all. And here is dest. Right now it is empty. strcpy will fill it, one character at a time. First, strcpy copies the H down into dest at position 0. Next it copies the E, then the first L, then the second L, then the O. Now dest holds the word hello. Last, strcpy copies the null terminator \0. This is the important step. Without it, dest would not be a valid string. Now the real danger of strcpy. It does not know the size of dest. It just keeps copying until it hits the null terminator in source. If source is longer than dest can hold, strcpy writes right past the end of the buffer, corrupting whatever memory sits beyond it. This is a buffer overflow. One of the most damaging bugs in all of C. The safer choice is strncpy, string n copy, which takes a size limit so it cannot run past the end. Now strncpy, the safer copy. It takes a third argument, the maximum number of characters to copy. Here we copy at most dest size -1, which is 9 characters. The source hello, world is 13 characters, so it gets cut short. Look at the extra line after the strncpy call. We set dest at index dest size -1 to the null terminator by hand. The next slide explains why. The output is dest hello, space WO. There is a critical gotcha with strncpy. If the source is n characters or longer, strncpy copies exactly n bytes and then stops. It does not add a null terminator, so you could end up with a string that has no terminator, and printf would run off the end reading garbage. The fix is a two-step idiom that you should always use. First call strncpy with the size -1. Then set the last byte to the null terminator yourself. Never assume strncpy terminated the string for you. Do it every time. Just like copying, comparing has a trap. You cannot compare strings with the double equals sign. Here we have two arrays and b both holding hello. You might expect the double equals b to be true, but it is false. The double equals operator compares the two memory addresses, not the characters inside. The two arrays are separate, so they sit at different addresses. The contents are identical, but the addresses are not, so the comparison is false. To compare the actual characters, you use strcmp. Now strcmp, string compare. It compares two strings character by character. We compare apple with banana and apple with apple. The output shows a VSB is -1 and a VC is 0. The key thing to learn: 0 means the strings are equal. A negative value means the first string comes before the second in dictionary order. A positive value means it comes after, and the exact values are implementation defined, so do not rely on getting exactly -1 or +1. Just check the sign. This table shows how to read the return value of strcmp. If it returns 0, the two strings are identical. That is the most important case. If it returns a negative value, the first string comes before the second in dictionary order. For example, apple comes before banana because lowercase is less than lowercase b. If it returns a positive value, the first string comes after the second. And here is the rule. Never compare against -1 or 1 directly. Different libraries return different magnitudes. Always test against 0, or check the sign with less than 0 or greater than 0. The most common thing you do with strcmp is check whether two strings are equal, and that means testing for 0. Here we check if strcmp of name and admin equals 0. If it does, we print welcome administrator. Read it out loud like this. If strcmp returns 0, there is no difference between them, so they are equal. This is the opposite of what beginners expect. 0 does not mean false here. 0 means no difference, which means equal. Getting this backwards is a very common bug. Now strcat, string concatenate. It appends one string to the end of another. We start with greeting holding hello in a 50-byte buffer. First we append comma space. Then we append world. strcat changes greeting in place. It finds the null terminator at the end of greeting and starts writing the new characters right there. Notice we gave greeting 50 bytes of room. That matters. The output is hello comma space world. This is dest. It already holds the word hello. And here is src, the string we want to add. It holds a comma, a space, and a null terminator. First, strcat walks across dest looking for the end. It passes over h, ello. It stops at the null terminator. That marks the end of hello. This is where the new text will go. Now strcat writes the comma right here, on top of the old null terminator. Then it writes the space. Finally, it adds a fresh null terminator at the new end. Now dest holds hello, comma, space, and it is a valid string again. Now the safer version, strncat. It appends at most end characters. The trick is calculating how much room is left. We take the buffer size, subtract the current length using strlen, and subtract one more byte for the terminator. That gives remaining. Then strncat copies at most that many characters. One nice thing, unlike strncpy, strncat always adds a null terminator after the characters it appends, so you do not have to add it yourself. But you must recalculate remaining each time because the length changed. This table sums up buffer safety. Every function that writes to a buffer can overflow it, so prefer the bounded version each time. For copying, use strncpy plus a manual null terminator instead of strcpy. For concatenation, use strncat with a calculated remaining instead of strcat. For reading input, use fgets with a size instead of scamp with %s. The golden rule ties it all together. Never write to a buffer without knowing its size. This one habit prevents the most common security bugs in C. Let's recap. The string.h header gives you tested functions for strings. strlen returns the length, not counting the null terminator. strcpy and strncpy copy strings, and remember that strncpy may not add the terminator, so you do it yourself. strcmp compares strings, and 0 means equal. strcat and strncat join strings, and strncat always terminates for you. Above all, prefer the bounded functions and never write to a buffer without knowing its size. Next, you have mastered arrays, strings, and the library functions that work on them. But why can functions modify arrays? The answer is pointers. In Chapter 6, Pointers in Memory, you will find out.